In the first four modules, we dealt with a lot of pre-algebra topics. Review from pre-algebra. This is the first module where we really get into the meat of algebra, doing actual algebra. So first I want to take a minute to talk about the question, what is algebra exactly? What is a variable? What is this used for? And I want to start by just talking about an example. Let's say you're trying to find the area of a rectangle. And you know that you do 3 times 5 for this rectangle, and the area of that is 15. If you have a rectangle that's 7 by 7, you take 7 times 7 to get 49. If you have this rectangle that's 2 by 8, you take 2 times 8 and get 16. We're talking about specific examples. When you talk about algebra, it's when you put a letter in, a variable in, to talk about what happens in the general case. Anytime you have any rectangle with a length and a width, to find its area, you take the length times the width. The use of those variables, those letters, to represent not just specific lengths, but every length that could happen. That's the idea of algebra. Using a generalization, making it abstract, talking about every situation, not just certain situations. Another example. Let's say that you want to change from degrees Fahrenheit to degrees Celsius. So let's say you have 32 degrees Fahrenheit, and you want to change that to degrees Celsius. Okay, what you do is you take the 32 and you subtract 32, and then you multiply that result by 5/9. And that'll change you to degrees Celsius. Okay, here's another one. Let's say you had 64 degrees Fahrenheit. And you wanted to change to degrees Celsius. You would take 64, subtract 32, and multiply your result by 5/9. I've done 2 specific examples, shown you 2 arithmetic problems. What algebra does is it says, okay, I don't just want to change from 32 and 64, I want to have some way of showing that I can change any Fahrenheit to Celsius. So we use an expression. This formula, this use of variable, tells me that I can take any degrees Fahrenheit and change it into Celsius. I have made a generalization about all the Fahrenheit degrees, not just the specific ones I have listed. And that's what algebra is. Arithmetic takes specific situations. Algebra is more abstract. It deals with every situation. So we're going to get into some of the vocabulary that has to go with algebraic expressions. Here are some examples down here of some different algebraic expressions. Let's look at some expression vocabulary. An expression is a group of terms. It has no equals sign. An equation has an equals sign in it. Expressions do not. So down here in this example, this whole thing is the expression. Terms. The things in an expression that are added or subtracted together. So for example, 5x squared is a term. Positive 3x is a term. And negative 2 is a term. It usually contains a number and a letter. So sign, number, letter. Sign, number, that one doesn't have a letter. But it's the things that are added or subtracted together. Those are the terms. Variable terms. Variable terms are the terms that have the variables in them. So this one's a variable term, and this one's a variable term. Constant terms are the terms that have just a number. They don't have a variable in them. So in this expression, I have 2 variable terms and 1 constant term. Coefficients are the number part of a variable term. So for example, in this variable term, 5 is a coefficient and positive 3 is a coefficient. Variables are the letter part of a variable term. So the x in our variable terms are the variables. Let's practice a little bit with this vocabulary. We will use all of these expressions to practice. Again, these are expressions. They contain terms. They do not have equal signs. That's what makes them expressions, not equations. This first expression has 2 terms, the 2a and the negative b. So those are the terms. It's important to include the sign with the term. The variables. The variables are the letters here. A and b are our variables. The coefficients are the number part of the variable term. So in the first term, 2a, the coefficient is 2. The coefficient is hidden here. Negative b is the same as negative 1b. So the coefficient here is actually negative 1. And there is no constant term. There's no number all by itself. In this next long expression, I'll just underline the terms. 8xyz, positive 9x squared y to the 5th z, negative x, positive 2y, negative 3, positive xyz squared. Again, number letters. Sign number letters. Sign number letters. There's no number in that one. Sign number letter. Sign number. The sign is your switching point. It's important to be able to see algebraic expressions as groups of terms. Next, the variables. The variables are the letters in the expression. So x, y, and z. Next, coefficients. The coefficients are the numbers at the beginning of each variable term. So the first term, the coefficient is 8. The second term, the coefficient is a positive 9. The third coefficient is kind of hidden. Again, when there's no coefficient, it's a 1. Negative 1 would be our coefficient there. Positive 2. And the very last one here, there's nothing there, so it would be a positive 1. Notice I skipped the negative 3. That is a constant term. A number all by itself with no letters attached. The next expression, there's just one term, xab. The variables are the letters in the expression x, a, and b. The coefficients, that's the number in front. There is no number in front, so we assume a 1. And the constant term, there is no number all by itself, therefore no constant term. The next expression. What are the terms? 3x to the third is the first term. Negative 5xy is the second term. Positive 8x squared y is the third term. And negative 6 is the fourth term. What are our variables? The letters x and y. What are the coefficients? the numbers at the beginning of each term. 3, -5, +8. There is a constant term. There is a number all by itself, -6. The last one. There's just one term here, the 3. There are no letters, so there are no variables. Therefore, no coefficients, no numbers in front of the letters. There is just a constant term here. The constant term is 3. Below this, I have included a link that gives more formal definitions of these terms along with more practice. It also includes degree of an expression, which we do not cover here until the polynomial module. So you can look at that if you feel like you need more practice.